Hello everyone. In this video we will talk about the 4 essential steps to writing a supervised learning program, whatever technique you want to use. Let's get started. First of all, and as a first step, the problem must be identified and it must be judged whether or not to use machine learning to solve it. For example, as we mentioned in our first video, a tic-tac-toe game, all it needs is a simple program with a limited number of conditions to be created, so a program to decide how much water to irrigate a garden taking into account its area, ambient temperature, humidity, etc., is a delicate and difficult problem to implement without using machine learning. Also in the first video, we saw that the machine learning consists in giving a machine the ability to learn without programming it explicitly. One of the strategies we can use is supervised learning, which consists of collecting and showing the machine examples of X and Y, and asking it to find the association that links X to Y, in fact an association Y equals f of X. These examples that we show to the machine, we have to put them in a dataset called learning base, and this is our second fundamental step in supervised learning. In supervised learning, our learning base always contains two types of variables. On the one hand, we have the target variable. That's our target. That's what we want the machine to learn to predict. For example, the price of an apartment, a breast cancer is benign or malignant, an email is spam or not spam, or the amount of irrigation water in a garden each day, and on the other hand, we have the characteristics. The factors are so-called features that influence the value of y. We can say that y is a function of all these features y equals f of x1, x2, x3. For example, we can say that x1 is equal to the area of the garden, x2 equals the ambient temperature, x3 equals the humidity, x4 equals the amount of rain, of course x4 equals 0 if it does not rain, and so on. So one thing you need to know is that by convention, we write lowercase m. The number of examples we have in our dataset, that is, the number of lines. And we will also note lowercase n. The number of features we have in the dataset, that is to say the number of columns except the Y column. Another convention we have is that to designate a particular cell in our learning base, for example, this cell, we will note the number of the example above the X and the number of the feature below. This cell is the cell X23, so it is the third feature of the second example we have in our dataset. So in the end you'll have a learning base that looks like this, where at the time you want to translate it into a vector and a matrix, you'll have a feature matrix with m rows and n columns, and a target column vector of m elements. And we're going to use this type of vector and matrix in the next videos. The third fundamental step is the creation of a model, or hypothesis. Indeed, from the training database we can visualize a scatter plot, for example here the quantity of irrigation water in function of the area of the garden. And we can say that we could create a model, for example a linear model, in which case we would have a model f of x equal to w1x plus w0. We could say no, it seems that a polynomial model fits better in the point. In this case we would have a polynomial of degree 2, f of x equal to w2x squared plus w1x plus w0, or a polynomial of degree 3. You understand that we have a model and this model has parameters wi. These are the coefficients of polynomials, as many coefficients as we have. This is what we call the parameters. It is important to specify that we determine which model the machine should use, and you will see that it is the machine that has to learn the parameters of this model. To have a good model is to have a model that gives us the smallest possible errors between the f values of the x's of the learning base and their corresponding y's. To do this we use what is called a learning algorithm. This algorithm is a strategy that tries to find which parameters wi give the appropriate model. There are many learning algorithms, one of the best known is the gradient descent algorithm. And we'll see in the next videos how to use it. A fourth and final step to ensure before moving on to the use of our model. This is the test step of the model. In fact, an algorithm alone is not enough to guarantee that a model works well on examples that do not belong to the learning base. This means that the model may not be able to generalize on examples it has not seen before. For this reason, another so-called test base is needed to ensure good model prediction. Now, here we have illustrated these 4 steps with an example of a regression problem. But remember, in supervised learning, there are also classification problems. The same steps will also be valid for these problems, with some modifications to the structure of the learning base and the learning algorithm. Well, that was all for today. If you have any doubt, feel free to add your question in the comment section. Thank you.